Section 1.1 talks about exponents, and what exponents in reality mean are repeated multiplication. So let me focus right here on 3 to the fourth. The 3, the bigger numbers, are what we call the base, which is the number is going to keep on being repeated. And then the little 4, that's what we call exponent, or sometimes people call it powered. That's what means how many times the base is going to be repeated. So 3 to the fourth, notice how I have 3 times 3 times 3 times 3. I have 3 4 times. So remember, exponent means repeated multiplication. So an example for our homework, let's take a look at an example. Let me do 5 to the second. Find the value of each exponential expression. 5 to the second. What that means is 5 times 5. So we have to find the value. I'm going to call this 25. Remember, 5 2 times. Now here, 6 to the third. What that means is 6 times 6 times 6. So I'm just going to use a calculator for that. 6 times 6 times 6, 6 to the third powered. According to my calculator, it is 216. Here, 2 to the fifth, it just means 2 times 2 times 2 times 2 times 2, right? 2, 5 times. So we multiply that out, and that happens to give us 32. Now, even on a fraction, looking at my example D, notice how the whole fraction is inside parentheses and the exponent is on the outside. So that means we're repeating the whole fraction. So 2 over 3 times 2 over 3 times 2 over 3. I want to do it 3 times because that's what the exponent says. Now just looking on the top, 2 times 2 times 2, that's 8. Looking at the bottom, 3 times 3 times 3, that's 27. So my answer it is 8 over 27. Notice at the beginning I said the entire fraction is inside parentheses. If it was not, as an example, let's say I had 2 to the third over 3. Notice how only the 2 is inside parentheses, so only the 2 gets repeated 3 times. So my answer should be, on this case, 8 over 3, because only the 2 gets repeated 3 times. The 3 at the bottom is just a 3. Now looking at my example E on decimals, it works the same thing. 0.3 times 0.3, and that gives us 0.09, right? We know how to multiply decimals, so that's all we do. Remember, exponent means repeated multiplication. Now, moving along, the next thing we're going to be looking at is what we call the order of operations. Probably you guys have heard PEMDAS, and if you guys are familiar with PEMDAS, then go with PEMDAS. But the way I look at order operations, what I use is GEMS. So let me do GEMS. What the G stands for is groups. The groups can be represented as a parentheses, like 3 plus 5. That could be a group, inside of parentheses. Another way that a group can be represented in a fraction, but one of the sides is not simple, like 3 plus 5 over 2. So in that case, 3 plus 5 is also a group. So groups first, remember it could be represented as a parentheses or in a fraction, one of the sides of the fraction is not simplified. So that's the first thing that we do. Then we do exponents. The second step is exponents. And we just saw what an exponent is, like 2 to the third. That gives us 8. So that's what we do later. Exponent is the second step. Now the third step, and this is why I prefer GEMS instead of PEMDAS, the third step means multiplication and division. So multiplication and division are treated at the same time. So if we see more than one operation, that it's either multiplication or division, we see it more than once, we treat them from left to right. Kind of like how we read. We read from left to right. Same thing with multiplication division. If we see more than one, what I mean with that is, let's say I had 2 times 3 times 5. So you see more than one operation, so you treat the one on the far left first, right? We go from left to right. Now, the last thing, the S for gems, that means subtraction and addition. I abbreviated a few words of multiplication, subtraction, I abbreviated those. So the last thing is subtraction and addition. So we add and subtract at the last step. The only way we're going to add or subtract before the last step is if it is inside a group. Otherwise, subtraction and addition is the last thing. So that's how we're going to treat gems for order operations. So as an example, find the value of each expression. So first thing I think of groups. I see no groups in my example 8. Then I think of exponents. I see no exponents. Then I think of multiplication and division. This case, I have a division, 12 divided by 3. I know that is 4. Notice I'm ignoring the minus at the beginning. So I'm just looking at 12 divided by 3. That's 4. So now let me copy the rest. 24 minus 4. And we just have a subtraction, 24 minus 4. That's going to give us 20. Looking at my example B, I think of groups first. And I see the group inside the parentheses. 6 plus 11, that's 17. So let me copy the 9 on the outside, right? Notice I only worked the parentheses. And then 9 times 17, we can use a calculator for that. 9 times 17, that gives us 153. Now looking at my example C, first thing I think of groups. I see none. Then exponents, I don't see any. Multiplication or division, I see two cases. I see 6.8 and I see 5 times 2. So 6 times 8, I'm going to call that 48. 5 times 2, I'm going to call that 10. But then I'm going to keep the plus sign in between them. Then the last thing that I do is add or subtract 48 plus 10. I'm going to call that 58. Same thing for my example D. I see division and multiplication, right? First, I see no groups. I see no exponents. Now, in multiplication division, I see two cases, but I have to do the one on the far left first. 48 divided by 2, so that gives me 24 times 3. 24 times 3, that gives me 72. So that's my answer. Remember, groups first, exponents, then multiplication, division, and the last thing, subtraction or addition. Even if I put it like this, there's a few examples there. So I'm gonna think of groups first, and I see there's a group, right? There's represented as a bracket, but inside the group, there's even a smaller group. So I'm gonna work the smaller group, which in this case is 6 plus 5. 6 plus 5 is 11. So let me copy what I have. I'm not going to deal with the 2 first. I'm not going to deal with the big group yet. So I have 8 plus 3 times 11. I'm going to put in red what I'm working with. Notice how the only thing that I did was the small group, 6 plus 5, so that's what I called 11. Still looking inside the group, I have addition and I have multiplication. When two numbers are put together, that means multiplication. I have to multiply before I add. So just looking at the group, just looking at the brackets, I'm not going to do anything to the two outside. For the inside of the brackets, I'm going to have 8 plus 33. And 3 times 11, that's what gave me 33. So now just the brackets, 8 plus 33, that is 41. So that's a group with the 2 on the outside. And I say when two numbers are put together, two separate numbers are put together, that means times. 2 times 41, I'm going to call that 82. Looking at the example B, first, I'm going to deal with the top of my fraction, because remember I said groups, it can be represented as a parentheses or it could be represented in fractions. So I'm going to deal with the top part, so that's what we're going to call a group, and I'm going to have 4 times 8 plus 3. Notice how I simplified my group, 5 plus 3, I simplified it at 8, because that was the group first. Now I see no groups, I see no exponents, I see multiplication. Remember, I'm just working the top of my fraction. So I see a multiplication, 4 times 8, that is 32. plus 3. So that's going to simplify to 35. Right? Notice I was just working the top of my fraction. Now looking at the bottom, I see times and I see minus. Remember, first I look at groups, none. Exponents, none. Multiplication or division, I'm going to do the multiplication. 3 times 2, that's 6. So that simplifies to 6 minus 1. Right? Remember, all I did was 3 times 2. 6 minus 1 is 5. So I'm just going to write it here, and then I'm going to copy it here again. It all simplified to 5. But then a fraction means division. 35 divided by 5 is going to give me 7. So that's our order operations. So remember, simplify the top, simplify the bottom. At the end, a fraction means division, so simplify that as well. Now we're gonna learn some symbols, some signs. So the symbol, we're familiar with that sign. It's an equal sign. What that means is that the two sides of the equal sign, so the left of it, the right of it, are the same thing. As an example, 3 plus 5 is equal to 8. Right? The left of it, 3 plus 5, and the right of it, of the equal sign, it's the same thing. Now, when we cross the equal sign, we mean that not equal to. As an example, 3 plus 5 is not equal to 7. Now, the sides are different, so we're going to say that is not equal to. Now, the inequality signs that kind of give us a little bit of trouble sometimes. The arrow pointing to the left, we call that is less than. What that means is the number at the left, it's smaller than the number at the right. So, for example, 5 is less than 7. So something like that. The numbers at the left, and it could be an operation. As an example, 2 plus 3 is less than 7, right? Because 2 plus 3, we know it's 5. So technically, the left side is smaller than the right side. As a thing is, many people say, many teachers say, think of that as an alligator mouth, and it's eating the bigger part. Some other teachers said, look at that as an arrow, and it's pointing at the little number. So however you guys want to see it, the way we read this is 5 is less than, because that's what we call the symbol, is less than 7. So remember, it's like an arrow pointing at the little number. Now here is greater than. Notice how now the arrow is pointing at the right. So the smaller number, remember the arrow is always pointing at the smaller number. So now my smaller number will be at the right. So something like that would be 7 is greater than 5. Notice how the small number now it's on the right side of the inequality. Once again, it could be simple numbers or it could be an operation like 3 plus 4 is greater than 2 plus 3. Right? We know 3 plus 4 is 7. 2 plus 3 is 5. So 7 is still greater than 5. Now, when we have the little line at the bottom, we call that or equal to. Notice how this one is very similar to this one, right? Those two are very similar. The arrow is pointing to the left. So we know the smaller number has to be on the left. But because it has the little line at the bottom, we're going to call that or equal to. What that means, it could be something like 5 is less than or equal to 7. Another thing that is going to be okay will be 5 is less than or equal to 5. Now, the reason why we do this, let me explain these things. When we have these less than or equal to, technically we have a less than sign and we also have an equal sign. If you see it, it's like right there. So we have a less than sign and we have an equal sign. What that means is one of the two is correct. Not both, but one of them has to be correct. In this case, 5 is less than or equal to 7. What is correct is the inequality sign. 5 is less than 7. If you notice on the right, 5 is less than or equal to 5. It is correct because we're going to be looking at the equal sign. Once again, there are two symbols. There's an inequality sign and there's an equal sign. And when we say the word or, remember how the expression says is less than or equal to, it means from the two signs that we see, one of them is correct. Same thing with this bottom part, is greater than or equal to. technically we have an inequality sign, but we also have an equal sign. So from the two signs, one of them is correct. So an example we could use is 8 is greater or equal to 2, because we know 8 is greater than 2. But at the same time, we can say 8 is greater or equal to 8, because 8 is equal to 8. So remember, it's either the inequality sign or the equal sign that is correct. Having that said, let's take a look at these. Determine whether each statement is true or false. So I see the not equal sign. The left side is 6. The right side, if we simplify, 5 plus 1 is also 6. It's telling us when we use this symbol, it's saying the two sides have to be different. In this case, it's not. So that's a false statement. Looking at my example B, let me simplify the left. 5 plus 3. And let me just copy what I have left. 8 is less than 19. That is true. Remember, I said the inequality, the arrows pointing at the small number. So yeah, that is true. Looking on my example C, I'm going to have 15 is less than or equal to 40, right? 20 times 2, that gave me 40. Remember, the arrows pointing at the small number, so 15 is less than or equal to 40. That is true. Now here, 25 is greater than or equal to 30. So looking at the inequality sign, 25 greater than 30, because remember the arrow is always pointing at the small number. 25 greater than 30, that's false. And then if I look at the equal sign, 25 equals to 30, that's also false. So all this is false. Remember this, I broke it as 25 is greater than 30, 25 is equal to 30. In order for this to be true, one of these two had to be true. But since both of them are false, then I'm going to call this false. Now looking at my example E, remember I can split my inequality. I can split that as 12 is greater than 12 or 12 is equal to 12. Remember there are two symbols, the inequality or the equal sign. I know 12 is not greater than 12, so that's not true. But 12 is 12, so I'm going to call this statement true. Remember for this inequalities, because it has the phrase or, I mean the word or, in this case greater than or equal to, then as long as one of them is true, then it has to be true. Now when we have fractions, it's good if we have no fractions, so get rid of them if we multiply both sides by 15. But usually in fractions, what we do, we try to have the common denominator, so the number at the bottom has to be the same thing. So 2 over 3, let me change this out. Let me multiply each of these two numbers by 5. So on the top, 2 times 5 gives me 10. At the bottom, 3 times 5 gives me 15. Now that I have the same denominators, I'm just comparing the numbers on the top. 6 and 10. And obviously the inequality sign. So 6 is greater or equal to 10. So I'm going to split that as 6 is greater than 10. 6 is equal to 10. The first one is not true, because the small number is not 10. Remember, the arrow points at the small number. So the first case is not true. 6 is not equal to 10. That case is not true either. So in this case, my statement will be false. Now, obviously, let's practice our words. Write each word statement in symbols. Symbols is how you usually see math. Sometimes we don't call it symbols, we call it algebraic expression. So let's work this thing out. 12, the number 12, that's, we know that as 12. Then I have the phrase is equal to, so I'm going to write an equal sign. And then after that, I see the phrase 10 plus 2. So I'm going to write 10 plus 2. And that's basically all you asked to write in symbols or algebraic expression. 9, I see the 9, is less than, we talked about inequalities already, is less than 10. One thing though, for inequalities, they always start with the word is. So is less than started with the word is, so that is an inequality. I'll deal with it later when it is not is at the beginning. If it only said less than, not is, we're gonna cover that later on. But remember, inequalities always start with the word is. So now looking at this other example A, 15, I'm just going to write 15, is not equal to, so is not equal to, and then 18. Now here from this other example B, 7 is greater than, once again, inequalities always start with the word is, so is greater than 4. And the last example, 13 is less than or equal to 40. So that's all we're asked in this case. And finally, oh, I have one more example here. 6 is greater than or equal to 6. Notice how my expressions, I wrote them, but I was reading them little by little, so don't read them all at once. It's okay if you go step by step. Now here, on this last thing, write each statement as another true statement with the inequality symbol reversed. So I want this, but instead of a greater than, I want it to be less than, right? I'm gonna reverse the inequality. And then I wanted to write another statement that is the exact same thing. Remember I came in and said the arrow always points at the small number. So the 2, instead of being on the right, I'm gonna put it on the left. 5 is greater than 2 is the same thing as 2 is less than 5. So when you flip the inequality sign, make sure you flip the numbers as well. Same thing here. I'm going to flip my inequality sign. Instead of less than or equal to, I'm going to write greater or equal to. But just like I did on example 8, reverse, flip your numbers. My 3/4 on the right, on the left, and my 1/2 on the right. So that's what it means with write each statement as another true statement with the inequality symbol reversed.